So continuing with Sec 1 2012, the analysis, the Calc active analysis section, we're up to part G. So the graph of g of x undergoes some transformations. So we had g of x defined over here, and we can do those transformations directly on the calculator. So a reflection in the x-axis is a minus, a dilation factor of 2 from the y-axis would be half x, and a translation of 1 unit to the left. We've got to be careful there because it's actually going to be x plus 1 in brackets. So that's that is the function form for these particular transformations. We're told though that a equals 5, so really we should put in a little goalpost and make it clear that a equals 5. We enter now, we've got an expression for a function that expresses those transformations. I can drag that in here, and probably a good idea is to define that just to make it easier, and I'm going to define it as h. And so the function h of x is g of x after undergoing all of these transformations, and I want to now work out the coordinates of the x-intercepts and the stationary point. Well, the x-intercepts occur when h of x equals 0, so I'll go ahead and solve that for x, and I get 3 and 7. So it kind of suggests, looking back at our graph that we had earlier, that 3 and 7 might be some coordinates. There is a reflection around the x-axis, so this graph would reflect with this minimum being a maximum. So you could sort of intuitively suggest that we're going to go with f max of h of x between those x-intercepts 3 and 7 and get a result. So you get a y value of 52.53, but we could also sketch the graph, and if you look at the graph, that's what it looks like. This is a graph of h of x, and we could use gsolve to give us the maximum, and there it is, 5.42 and 52.539. That was part 1, G part 1, and G part 2 looks for a new equation of the transform function of g, but it's in this form. We can see, just resize that, we can see from this function here that it's not really, I wonder if I rotate, if we'll see the whole thing. It's a bit difficult to see. We can see from here that that looks nothing like that. It doesn't look like it's in that form at all. But perhaps if we use the simplify function, and we want to simplify h of x, we might get something closer to the result. And there we have it. We do, in fact. We get a 16, we get an x minus 3 and an x minus 7, and the only difference is that instead of ax squared plus bx plus c, there's a minus out the front, but there shouldn't be a 3 out there. So if we multiply this 3 inside, we'll have 3x squared plus 16x plus 45. So that suggests that a is 3, b is 16, and c is 45.